Hello, you're welcome. Today we have this advanced improper integral problem. We have the integral from negative infinity to positive infinity, 1 divided by the secant of x squared plus 3x minus 5 dx. Right? Let's call this integral I. Now we know the relationship between the secant function and the cosine function, right? We know the cosine of theta is equal to 1 divided by the secant of theta, right? So it also implies that 1 over secant of theta will be equal to the cosine of theta. So here, I is same as the integral from negative infinity to positive infinity. So this is going to be the cosine of the quadratic expression, which is x squared plus 3x and then minus 5. And then we have our dx. Now we're going to complete the square of this quadratic expression, right? So how are we going to go about that? Okay, now let us recall that a plus b whole squared is equal to a squared plus b squared and then plus 2 times a times b. Now, x squared plus 3x minus 5 is same as x squared, so something squared, as we have a squared here, right? Then we're going to have another thing squared. What's that? Okay, let's talk about 2ab. So we're going to have 2 multiplied by x. Remember we have 3x, at least we need a 3x. So this is going to be multiplied by 3 all over 2. You get the idea? We know 2 cancel 2, we still have our 3x. Okay, now from here, b is squared, right? And that b is what we have right over here. Okay, so here we're going to square 3 all over 2, which is giving us 9 all over 4. Then remember we need to obtain a negative 5, which is telling us to subtract negative 29 all over 4. You get the idea? So here, this is indeed a perfect square, which is equal to x plus the 3 all over 2 whole squared, right? Okay, and then minus, here we have 29 divided by 4. So we are done completing the square. So therefore, our I is equal to the integral from negative infinity to positive infinity. So the cosine of x squared plus 3x minus 5 dx is going to be equal to the integral from negative infinity to positive infinity. The cosine of x plus 3 by 2 whole squared minus 29 divided by 4 and then dx. Okay, now let us recall about the sum angle of the cosine function. So we have the cosine of a minus b is equal to the cosine of a multiplied by the cosine of b, then plus the sine of a multiplied by the sine of b. So we're going to apply this here. So our I is going to be equal to the integral from negative infinity to positive infinity. So this is going to be the cosine. Oh, before that, I think we need something really cool. Okay, there's no problem, but we're supposed to have made a substitution, right? That is calling x plus 3 over 2t. So I think that is the first thing to do. Oh, so sorry for that. So let's go back and make the following substitution because that would be more necessary. So the right substitution here is we're going to let x plus 3 over 2 equals t. So for x, x is equal to t minus 3 all over 2. Differentiate both sides, we get dx is equal to the t. Now, when x is approaching negative infinity, t is also approaching negative infinity plus 3 over 2 is negative infinity. When x is approaching positive infinity, t will also approach positive infinity. This is really cool. Therefore, our I is going to be equal to the integral from negative infinity to positive infinity. So it's going to be the cosine. Now we have t squared minus 29 divided by 4, and then dt. Now we can use that sum angle of cosine function. As we know, cosine of a minus b is equal to the cosine of a multiplied by the cosine of b plus the sine of a multiplied by the sine of b. So we're going to apply this here, right? Therefore, our I is going to be equal to the integral from negative infinity to positive infinity. It is going to be cosine of t squared multiplied by the cosine of 29 divided by 4. Then plus sine of t squared multiplied by the sine of 29 divided by 4, right? And then we have our dt. Okay, now so from here, I is equal to the integral from negative infinity to positive infinity. We have the cosine of t squared multiplied by the cosine of 29 divided by 4, right? dt. Then plus the integral from negative infinity to positive infinity. We have the sine of t squared multiplied by the sine of 29 divided by 4, and here we have our dt. Now the constants, we're taking them outside. So we have I is equal to, this is going to be cosine of 29 by 4 multiplied by the integral from negative infinity to positive infinity. We have the cosine of t squared dt, and then plus the sine of 29 divided by 4 multiplied by the integral from negative infinity to positive infinity. We have the sine of t squared and then the t. One thing you need to know is that this function here is even, right? And this one here is also even. But let me tell you, why the sine of t squared is even is because of the t squared there. The t squared is even. For all negative values of t, it is positive. Do you understand? Now we're going to use this nice integral standard formula. We know that the integral from negative a, should I use a? I think it is more convenient to use a. So from negative a to positive a of an even function of x dx, that this is equal to twice this integral running from 0 then to infinity of that same even function of x and then dx. So using this here, our I is going to be equal to, we have cosine of 29 divided by 4 multiplied by, then we have the twice the integral from 0 to infinity, right? So we have the cos of t squared and then the t, plus here we have sine of 29 divided by 4 multiplied by 2 times the integral from 0 to infinity of the sine of t squared and then the t. And we know from our previous video, using the Mellins transform, we found out that the integral from 0 to infinity of cosine of x squared dx, that it has the same value with the integral from 0 to infinity of sine of x squared dx, which give us square root of pi divided by 2 root of 2. Think of when you multiply it by 2, it will only give us square root of pi over square root of 2. Therefore, I is going to be equal to the cosine of 29 divided by 4, then 2 multiplied by the square root of pi divided by 2 root of 2. And here plus sine of 29 divided by 4, then multiplied by 2 times the square root of pi divided by 2 root of 2. These get cancelled with this get cancelled with this. Square root of pi over square root of 2 is same as square root of pi divided by 2 like this, then cosine of 29 divided by 4 plus square root of pi divided by 2 sine of 29 divided by 4. So this is our solution, but we can factor out the common, which is square root of pi over 2. So we get the square root of pi divided by 2, then into bracket cosine of 29 over 4 plus the sine of 29/4. So this right over here is our solution. Thank you for watching. Please, if you really enjoyed this video, kindly support this channel by subscribing. Also like, comment and share.